Running a simulation in Kinetic Model Builder requires two objects, a model shown in the left window and a protocol shown here in the right window. For this example, we're using a simple two-state model which transitions from a resting state to an active state with the resting to active transition depending on the concentration of some drug. For our simple protocol, we simply have three different pulses of various drug concentrations, which we can step through. So running a simulation involves first selecting the type of simulation you'd like to run in the toolbar of the model window of the model that you're going to simulate. There are two possible types, Eigensolver and Monte Carlo. The Eigensolver approach solves the system of differential equations for the transition rates between states by diagonalizing the matrix of transition rates. And the Monte Carlo approach generates a Markov chain of state occupancies with respect to time. Does this for some number of specified runs and then averages the runs together to obtain the time-dependent probability in each system state. For a more in-depth description of these two methods, please see the user's guide. So actually running a simulation once we have our model and protocol is as simple as choosing the type and pressing simulate, or from the model menu selecting simulate. So we now have ran our simulation. We actually don't see anything here because for the moment we haven't specified to look at any signals that were simulated. So what we'll do is look at the state probabilities. And just to make this more clear, I will remove the drug pulses from the other axis. Okay, here's our simulated state probabilities. In blue, we see our resting state, and in red, we see our active state. And we have three different simulations because we specified three different drug pulses. So to just look at the first drug pulse, here we have our resting and active state probabilities. And I'll put the pulse on once more just so you can see that. And that's in response to our drug pulse. If we go to our next pulse, which has higher amplitude, we now see that we're activating more quickly. And the last pulse, which is even higher amplitude, we activate even more quickly. To perform a Monte Carlo simulation of the same system, we simply select Monte Carlo and press simulate. And it will generate the average Monte Carlo response for, in this case, 1,000 runs. Of course, if we increase the number of runs, we should come closer and closer to generating the outcome produced by the Eigensolver method. And for Monte Carlo, if we were to set this to one run, we would of course generate the sort of single system copy. Here's the resting state, then it goes into the drug state, then back to the resting, then back to the drug. But typically we'd like to look at the average of a whole bunch of runs. To save the simulation to file, we simply click on the axes of the plot and select Export Visible to either .text or .svg. The first exports all of the visible displayed signals to a column delimited text file, and the second exports it to a vector graphics SVG file, which is useful for both saving your data and generating figures.